Okay. Cat is to kitten as dog is to puppy. Yay. See, I know it was hard. Okay. Up is to down as left is to right. Woman is to girl as man is to. And driver is to car as pilot is to airplane. Okay. Now there is a method to my madness. You're looking at this going, that is not math, but it really is. Because an analogy, which is what we just did, is a comparison based on similarity. So that was the warm-up, was an analogy. A ratio is a comparison of two quantities using division. And a proportion is if you have two ratios that are equal to each other. A ratio and a proportion, these are the analogies of math. Okay, so if we were to take cat is to kitten, that would be our word ratio. Of course, we use numbers, two quantities. And the proportion is where you make the ratios equal. Cat is to kitten. Kitten has two T's in it. As dog is to puppy. Okay, so that's our word analogy. With our proportion, 2/5 is equal to 4/10. Because if I reduce this, they have the same values. They have the same relationship. A 2 is to 5 as a 4 is to a 10. Oh, wait. Proportions allow us to solve for missing values using what's called the cross products theorem, which tells me if A over B is equal to C over D, then I can multiply A times D and B times C. Cross multiply. Is what you've probably heard in the past. So if I look at this, 1 times 10, and then 2 times 5. 1 times 10 equal to 2 times 5. Why, yes, it is. They're both 10. Cross products work if you have a true proportion. If I had 1 over 2 is equal to 4 over 10, then I would have 10 is equal to 8. Not true, so that wouldn't be a true proportion. So whenever you have a true proportion, so you have two fractions that are actually equal, the cross products will always work. We can always use that, also use that to solve for x. So some examples, if I have x over 3 is equal to 2 over 5. Okay. I'm going to cross multiply. So 5, pen change. 5 times x is equal to 2 times 3, or 3 times 2, whichever. So 5x is equal to 6. Divide both sides by 5. 6 doesn't divide by 5, and that's perfectly okay. Just leave it as a fraction. Okay. Sometimes you don't actually have to cross multiply to solve these. Okay. 2 over x is equal to 4 over 10. You can see straight from here that I multiplied by 2. Everybody see that? So this would have also had to have been multiplied by 2. So what times 2 is equal to 10? 5. So if you can see what they multiplied by with one number, like this, then you can do the same thing to solve it. Or we can cross multiply and get 4 times x is equal to 2 times 10, or 4x is equal to 20. Divide by 4, and you'll still get your x is equal to 5. So if you have a situation like this where I have, 3 times what equals 5, I don't know, then you'll cross multiply for sure. If you have a situation like this where you can see they multiplied by 2, and you can solve this in your head easier, then go ahead and do that. But if you don't see it, cross multiplication still works. So more than one way to approach the same problem, as it were. And lastly, they could get a little bit more complicated. You could have something like x plus 3 over 10 is equal to 5 over 7. And I just made this up off the top of my head, so the math might not be pretty. We're still going to cross multiply, but I'm going to have to distribute that 7 to the x and to the 3. And then 5 times 10 is 50. So I get 7x plus 21 is equal to 50. Take 21 away from both sides. It almost worked nicely. Do you see that? It was so close. Divide by 7. And again, 29 does not divide by 7, so you can just leave it as a fraction, and that's okay. If you want, you can put it in and get the decimal. Then that would give me I just leave it as a fraction, it's less work. When I cross multiply this, I'm going to get x plus 2 times x minus 5, and then x minus 3 times x plus 4. Do you guys remember how to FOIL from algebra? Anybody need a refresher? Okay. So FOILing from algebra stands for first, outside, inside, and then last. And that explains the order that you multiply in. So if I have x plus 2 times x minus 5, for the first, the f part of the FOIL, I'm going to multiply x times x. And that gives me x squared. And then for the outside, I multiply the two numbers on the outside of the parentheses, so x times negative 5. So that's negative 5x. And then the inside, those are those two. I'm not going to write in green, though, because it won't show up. And then last, we'll do purple, is the last two numbers in the parentheses, so those two. Okay, then these numbers are going to be your like terms, and so they get added together. Good? Okay, so this is going to give me x squared minus 3x minus 10. And when I FOIL this, I'm going to get x squared minus 3x and a plus 4x and a minus 12. So I have x squared minus 3x minus 10 is equal to x squared plus x minus 12. And then you go, oh my gosh, I don't remember how to solve equations with squareds in them. And then I say, it's okay, look. They're going to go away. So you don't actually have to solve a quadratic. What did I just do? All right, so now I'm left with negative 3x minus 10 is equal to x minus 12. So I'm going to subtract x from both sides. I get negative 4x minus 10 is equal to negative 12. Add 10. Move over. Negative 4x is equal to negative 2. Divide by negative 4, and I get a fraction, and not a really bad fraction considering I made this up off the top of my head. You guys have done this. This is also known as reducing the fraction, which you have done a lot of, I'm sure, in your time. 3 over 9, both 3 and 9 divide by 3. And so you get 1/3. We're going to be doing this with variables. If you have x over x, the x's cancel. And you get 2 over 5. If we have both numbers that'll reduce and variables that reduce, we look at them separately. So let's say I do oops, that should have been x squared, sorry. Okay, I have numbers, I have x's, and I have y's. But I'm going to look at these as if they are separate things. I'm going to deal with the numbers, I'm going to deal with the x's, and I'm going to deal with the y's. So no matter how much is there, don't let it overwhelm you. Deal with one thing at a time. 12 and 16 both divide by anybody? Anybody? 4, yes. If you couldn't think of 4, you could always try 2 and then do 2 again. So I get 3 over 4. When you have the exponents, you're going to subtract the exponents. So subtract the exponents. And then you put the answer on the side of the bigger exponent. That's an E, but I don't know what happened with my pen there. So. Okay, so when I look at this, I have an x to the third and I have an x squared. So I'm going to do 3 minus 2. 3 minus 2 is 1. The 3 was the bigger exponent, so my answer goes on the top. Here I have a 1, because if there's nothing there, it's a 1, and a 5. So I'm going to do 5 minus 1, so that's 4. The 5 was on the bottom, so my answer goes on the bottom. And finally, I'm going to ask you, is this a proportion, or do these two fractions make a proportion? So the question is, do these make a proportion? Cross multiply. And then ask yourself, is that true? 2 times 12 is 24. 3 times 8 is 24. If this is true, then the answer is yes. Okay. If I have another one, okay, I'm going to cross multiply again. And I'm going to ask myself, is this true? 4 times 20 is 80. 5 times 15 is 75. So this is not true, so then the answer is no. That's the easiest way to tell if two fractions make a proportion or not. This looks harder than it is. Okay, we're going to find two complementary angles that are in a ratio of 2 to 1. We have to remember that complementary means that the sum equals 90. And if it was supplementary, it equals 180. So if it said supplementary there, it would equal 180. Okay, so complementary angles that are in a ratio of 2 to 1. Take these numbers right here and add x's to them. 2x, 1x. They're complementary, so that's going to equal 90. So 2x plus 1x equals 90, so that tells me that 3x equals 90. And if I divide both sides by 3, I get that x equals 30. My angles, this is angle 1. This is angle 2. So to find my answer then, angle 1 was 2x, which is 2 times 30, which is 60. And angle 2 was 1x, which is just 30. So take whatever you had here, plug your answer in, and that tells you your two angles. And so my actual answer is 60 and 30. Yeah.
Where did you get 30?
When I added these two together, 1 plus 2 gave me the 3. And then I divided both sides by 3, and that's where that 30 came from. We'll do it this one also. It's going to be the same process, but with 3 angles. Triangle adds up to 180, always, every triangle, in Euclidean space, which is where we live, so it's all good. So we have a ratio of 1 to 2 to 3, so I have a 1x, a 2x, and a 3x. So again, whatever these numbers are here, just put an x on them. Equals to the triangle, so it equals 180. So 1 plus 2 is 3, plus 3 is 6, so 6x is equal to 180. And I promise they will not always be 30. So don't just go around and just, oh, x is just always 30. It's not. But this time it is. So x is 30. My angles, this is angle 1, angle 2, angle 3. So angle 1 is 1x, angle 2 is 2x, and angle 3 is 3x from here. So this is 1 times 30, 2 times 30, and 3 times 30. And so my 3 angles are 30, 60, and 90, which is a very special right triangle that you guys will learn about in Unit 11? 10? 11? 10 or 11. Last examples in this lesson, and then we'll go on to the next one. We're going to simplify this ratio. I have a 15 and a 20. Those both divide by 5. So I'm going to divide by 5 first, and that gives me 3 over 4. And then I have a 2 and a 1. So 2 minus 1 is 1, and the 2 is on top, so my answer goes on the top. Good? Okay. Is this a proportion or not? I'm going to cross multiply. Does 5 times 14 equal 6 times 10? That is 70. This is 60. Anybody want to answer the yes or no part? Are those equal? No. Okay. So it's not a proportion because they're not equal. Find two supplementary angles that are in a ratio of 8 to 10. So we're going to do our 8x plus 10x. They are supplementary, so that means they're going to equal 180. 8 plus 10 is 18. And then if I divide both sides by 18, I'm going to get that x equals 10. Okay. And then angle 1 is 8x, which is 8 times 10, which is 80. And angle 2 is 10x, which is 10 times 10, which is 100. Good? Yeah?
So, on every problem like that, you're going to have to write angle 1 and 2.
You don't have to actually write angle 1 and angle 2. You can just tell me 80 and 100. I'm okay with that. But I'm just doing this for when you look at it later. But you will have to do this math part. Okay, let's say test question, and this was on the test, and you got the x, but you didn't do this part, you get half credit. Okay, then the last one, we're going to cross multiply, and that's going to give me 2 times x minus 1 is equal to 9 times 4. Distribute the 2. Multiply the 9 and the 4. Add 2 to both sides. And you get 2x is 38. And then when you divide by 2, you're going to get 19. Okay. We've talked about congruent pretty extensively. Congruent is the same shape and the same size. We did congruent triangles. We've talked about parallelograms, things that are congruent, things like that. Similar is the same shape, but not the same size. So, anybody seen the movie Honey, I Shrunk the Kids? Yeah, okay. They were similar. They were the same shape, but they were a different size. So, and that's what similar is. It's like somebody shot the triangle or the square or whatever with a shrink ray or an enlargement ray and shrank it or enlarged it. But the angles will be congruent. The side lengths will be in a proportion. So angles are equal, sides are proportionate. And if you think about proportions, like if somebody came in here and shot me with a shrink ray right now, I would be proportional. I would just be little, which would make my diet like extra, effective because I'd weigh a lot less. The symbol for similar is this little squiggle right here next to the escape key on your keyboard. It's called a tilde, in case anybody ever cared to know that. I had to look that up because I did not know it. Now I do. Huh? Tilde. It's a tilde. Huh. So, tilde. So here we have, these are similar. So A, B, C, D is similar to E, F, G, H. So that means that angle A will be the same as angle E. Angle B will be the same as angle F. Angle D, will be the same as angle H, and angle C will be the same as angle G. Those are all going to be the same. And then the side lengths, so you have AB and EF. Are in a ratio of 6:3. Every other set of sides is going to be in that same ratio, so that will be equal to BC over FG, which will be equal to CD over GH, which will be equal to DA over HE. And if you look at that, 6/3 reduces to 2/1. So whatever these numbers are, they would all reduce to 2/1. So like this maybe was like 10/5 or something like that. How do you know which sides are the same? If the angles are marked, that's what makes it the easiest, because the angles will be marked and then you'll go based off of that. But let's say like they're not marked. What I do is I look for some sort of distinguishing characteristic, like C is the most pointy angle. So, and G is the most pointy angle, so that would tell me C and G were the same, and then I'd go from there, which we'll do some examples like that. Like this. They're not marked, but I can see that, you know, this side is flat and this side is pointy, which tells me that this angle is the same as that angle. Okay. From there, when I look, I don't know if this has been flipped or not, so I look at this length versus this length, and I see that this is shorter and this is shorter than this, so that tells me that these sides go together. They match up. Then that tells me this angle will be the same as that angle. And then I just move around. This side is going to go with that side. This angle is the same as this angle. I'm running out of colors. This side will go with that side. This angle will be the same as that angle. This side goes with that side. This angle is the same as this angle. And then finally, baby blue. That goes with that. So basically, I started with the most pointy part and then moved around to match everything up. Now that I've matched everything up, I can start to answer the questions. Okay, Y and Z are both angles. Angles are going to be equal to each other. So I look and I see that both of these are the same. So Z is going to equal 145 degrees. And then I see that these angles are the same. So Y is 90. The angles are going to be the easiest to do because they're just going to be equal. The most you might have to do is if it's a triangle and you're missing an angle, you subtract from 180, right, to find the missing angle. But they'll just match. The sides, though, are going to be a little bit different. We're going to have to set up and solve a proportion. So when I look at this, the x and the 15 are going to go together. I'm going to put those in a fraction together. I can put either one on top. But if I do the small number or small shape over the large shape, I have to do the same thing over here. I can't do x over 15 here and then do 10 over 6 there. So whichever shape you put on top, small or large, has to be the same on both. I always put the little one on top because it appeals to my sensibility to not be top heavy, but it doesn't really matter. So do you want 15 over x or x over 15? Okay, so we'll do x over 15. And then I find the numbers that go together, 6 and 10. So 6 will go over 10 because the 6 and the x are on the same shape. So the same shape always goes on top. cross multiply. Divide by 10. And you have your answer. Okay, and I feel that the most difficult part of this can be matching up the things that go together. Because if you rotate at all, like C is rotated, and so that makes it a little bit more complicated. A is not rotated, so when I look at this, I'm going to see that this angle and this angle go, you can't even see that color sucks. Okay, this angle and this angle go together. This angle and that angle go together. This side and this side go together, and then that side and that side go together. But you can tell from the pictures being different sizes that can't be 9. But again, I have angles, and angles are the easiest one to do because they match. So y is 75 and z is 87. And now I have to solve to find x. So if I put x over 9, because those are the same side, and then 4 over 12. Now, if you see that this reduces and you want to reduce first and then multiply to make your division easier, you can do that, but you don't have to. I'm not going to, but you could if you wanted to. I get 12x is equal to 36. That's equal, not, I don't know what letter even that looks like, but that's an equal sign. Divide both sides by 12, and you get that x is 3. Now, how else could you have done this? When I look at this, 4 times 3 is 12. And I could have said something times 3 is 9 and divided by 3. So if you can see that, if you see what it got multiplied by, that's called the scale factor, you can use that. If you don't see it, you create the proportion. Okay. B, they look to be in the same orientation. So, wrong pen. This angle goes with that angle. This side goes with that side. This side goes with this side. That's not a different color. That side goes with that side. This angle with this angle, and that angle with that angle. Now Z is the same as this angle up here, but I don't know that angle, so I'm going to actually have to subtract from 180 because, as we have talked about, triangles always add up to 180. So I'm going to have to do 180 minus 62 and then minus 43. So 180 minus 60 is 120, minus 2 is 118, minus 3 is 115, minus 40 is 75. If I did that correctly in my head just now. I'm going to go to the next page to do x and y. So if we look at this, I have x over 4 and y over 6. Would it make any sense to make those equal to each other? Here, I'll write it down so you can see what I'm talking about. Can I solve that? Not really, because if I cross multiply, I'm going to get 6x is equal to 4y. I can't solve that. I'm going to go, okay, that's nice. So we don't want that situation. What you're going to do is you're going to look, and since I have 2 sets of variables, I need to set them equal to the side pair without variables. So if I put x over 4, I have to put 7.5 over 5. Oh, that's not a pen. Then I'll cross multiply. and then divide by 5. So first cross multiply, then divide by 5. And now I know x. Then I come back and do the same thing for y. I have y over 6. And I'm going to go back to the 7.5 over 5. If at all possible, don't use the x over 4, because even though I now know that that's 6 over 4, but if I did this wrong, that'll make my y automatically wrong. So I get 5y is equal to 45. Divide both sides by 5, and you get that y is equal to 9. So far, okay? Okay, so you can see based on this 90-degree angle that this thing has been rotated. So I'm going to go ahead and mark those as purple. Then for me, I'm looking at, based on this length is shorter than this length, not by a lot, but you can see that it is a little bit shorter. Everybody see that? So that side goes with that side. And then that would make this side go with that side. This side, white, that's not a good highlight color. This side go with that side. And then finally, angle-wise, this one would go with this one. And I could keep going around the whole shape, but I don't need to because these don't have any markings on them, so I don't really have to do anything with those. So I'm just going to stop there. Okay, angle-wise, I have y. So that one's done. Y equals 112. Proportional, I need to find z and I need to find x. X and 4 go together, z and 10 go together, and then 12 and 6 go together. Now, I look at this and I see that this has been divided by 2. So that tells me to divide 10 by 2, and then to multiply 4 by 2 to go the other way. And then that would be done very quickly without setting up proportions if you see it. But if you don't see it, set up the proportion. I'm going to do 4 over x is equal to 6 over 12. Cross multiply. And then divide by 6. Okay, which matches the times 2. And then here I'm going to go back to the 6 over 12 and the z over 10. So z over 10 is equal to 6 over 12. Cross multiply. Divide by 12. And you get your answer. Okay? Now your homework tonight is assignments 41 and 42, which happens to be pages 45. They're not numbered properly. Okay, so this doesn't, those in between is because the top page is 45. Then it says page 2 and page 3. And then it says page 46. And then it's page 5. Oh, wait, no, I did number them at the bottom. Okay, never mind. Pages 1 through 6. Just ignore me. Page 1 through 6. In the center of the bottom, go with those pages. So pages 1 through 6 evens are your homework tonight.